Let's go.
All right, now it says, I will read the problem to you. It says, experiencing a constant horizontal 2 meter per second wind, a hot air balloon ascends from a launch site at a constant vertical speed of 3 meters per second. At a height of 300 meters, the balloonist maintains constant altitude for 10 seconds before releasing a small sandbag. How far from the launch site does the sandbag land? Now, there's different ways you can do this problem, but there's a lot here. There's a lot here, okay? There's a lot of very subtle things here. This is not a projectile where you're shooting it up and it's governed by gravity. You know, if I throw a ball in the air and I throw it 50 meters per second, right? After 1 second, it's 40 meters. After 2 seconds, and then 3, then 5 seconds. If it's 50 meters per second, then after 5 seconds, it starts to come down again, right? This has nothing to do with projectile. Understood?
Yeah.
So the balloon is going to ascend at a constant velocity, constant speed of 3 meters per second for 300 meters, right? So it's going to get, so it's actually probably going to go like this. It's probably going to go like this, the balloon. Because you have this wind, this 2 meter per second wind, blowing, right? So it's constantly rising, 3 meters per second, right? Yes? And then it's going to rise and it's going to get to 300 meters. Correct?
Yes.
Easy?
Yes.
Okay. So it's probably going to rise like this. Right? Probably going to rise like that. Easy?
Yes.
Right. But the point is that it's going 300 meters up. Right? So it's going to go 300 meters vertical. It's going to go to 300 meters. Okay? It's going to get to 300 meters, right?
Yes.
And it's going 3 meters per second, right?
Yes.
Yes or no?
Yes.
So it's going to be the first leg. The first leg is going to go for 100 seconds, correct?
Yes.
If it's 300 meters, because why? Because it's going to be velocity equals distance over time, correct? Time is distance over velocity, correct?
Yes. Yes.
Yes? So then 300 divided by 3 meters per second. Yes? Yes? Yes or no?
Yes.
Right?
Yes.
Okay. So it's going to rise 300 meters and it's going to be going 3 meters per second. Okay? I know it's maybe going that way because of the wind, but the point is this. Listen to the question. It says, experiencing a constant 2 meter per second wind, a hot air balloon ascends from the launch site at a constant vertical speed of 3 meters per second. At a height of 300 meters, the balloonist maintains an altitude for 10 seconds. Okay?
Yes.
Make sense?
Yes.
So the first leg is going to be 100 seconds, and then the next leg is going to be 10 seconds. I can erase this, okay? Right? And it's going to continue to go. It's going at 2 meters per second, right? And now, this is going to go like this, right?
Yeah.
Now the question is, how far from the original launch place, how far from here to the sandbag hits? Now, the sandbag fell 300 meters, right?
Yes. Yes.
While it was moving 2 meters per second. So how long did it take the sandbag to fall 300 meters?
Donc on va faire distance over v below distance and velocity.
Now, that's a question of gravity. So it's going to be the time it takes to fall
Square root.
relative to gravity
Exactly.
is based on d equals 5t squared, right? D equals v naught t plus 1/2 gt squared. V is 0,
And then half g.
so it is 1/2 gt squared is 5t squared. Yes?
Yes.
So this is going to be 5, so this is going to be 300
Yes.
divided by 5, root 60. So what's root 60?
It's 7.7.
7, what is it? 7.7, okay. So 7.7 seconds. Correct?
Yes.
So, right? So, let's work over here. So, on your calculator, add for me 100 plus 10 plus 7.7.
It's 117.7.
117.7 seconds. That's correct, right?
Yes, that's right.
How fast is the balloon going and the sandbag? How fast is it moving? It's moving 2 meters per second, right?
Yes, yes, yes.
So the answer is going to be, what is this times 2? So what is 117.7 times 2?
235.4.
235.4
35.4
meters. You get it? You see?
Ah, yeah, that's what you mean. Good.